Sea otters are marine mammals in the mustelids family and are keystone species of their environment. Most of the research that has been conducted on sea otters up until now involves the physical capture or handling of individuals. This can induce alterations in behavior, physiology, and in rare instances, capture myopathy. As such, this project evaluates current methods of marking to determine which method results in the least adverse effects to sea otters while maintaining the integrity of data and maximizing ease of application.
The first on this list is natural markings. This method of marking is becoming a more widespread practice among marine researchers due to the reduction in risk when compared to other marking methods. Natural markings could have merit due to the frequency at which otters are being found bearing scars. Sometimes fur color is also used, but not as frequently nor as reliably. In terms of animal welfare, the use of natural markings is ideal because it results in no adverse effects on the otters, as the method of measure is digital imagery and photography. Additionally, the data produced in terms of population, abundance, and behavior has proven to yield accurate results. However, the stability of natural markings, such as scars and fur, is variable as they can change or fade over time. Manual photography can also be very labor-intensive and taxing. One study found a research team boating in bays for up to 9 hours taking manual photos of otters they encountered. Although manual photography is the most plausible way to get the imagery of otters needed, because you can't set up cameras in an ocean to reliably capture sea otters, a team would need to sort through the photos to ensure functionality before uploading them to their software of choice for evaluation and identification.
The next method is radiotelemetry, which uses radio signals transmitted by attaching an electronic device to determine location and relay biological information of an individual. Now, radiotelemetry can be used with two broad device types: an external device, like a collar or bracelet, or an internal device, such as implants. Radio tags are problematic for our project because the animal needs to be handled, regardless. Sometimes researchers can get away with not handling an animal by using electronically placed remote collars in a field, but because sea otters are mostly found in the water, we don't have the luxury of contactless collar placement, meaning the method of trapping and handling is the only option. Unfortunately, research shows that the use of external tags, such as neck collars and ankle bracelets, cause abrasions and swellings around restricted areas. One study even had instances of death. Sea otters have also been recorded pulling on the external attachments with their paws and mouths, which often leads to additional injuries. Otters are also capable of removing their neck collars due to their sleek bodies, which increases the probability of violating a major assumption of capture marker capture studies.
On the other hand, implants, while more invasive than external attachments, result in less injuries once they are successfully inserted. Previous studies examined that the signs of discomfort displayed in sea otters after surgical implantation fades after 18 hours. But the procedure is long and taxing and requires that the otter be captured, immobilized, operated on, and released with minimal recovery time. This is immensely stressful to the otters, and because the technology is so expensive, this is a process that can only be done with a small number of individuals. High effort, low output.
We'd like to take a moment to address passive integrated transponder tags, PIT for short, and why we didn't consider them in our analysis of marking methods. PIT tags are implantable microchips, a little similar to radiotelemetry implants. However, detection range is limited. It's impossible to use PIT tags to identify individuals from a distance, and in order to read them, the animal has to be restrained.
Our final method of marking is spraint. Spraint is a technical term for otter scat. It is a passive method of marking and allows the researcher to identify individual otters without needing to observe or disturb them. It is abundant and conspicuous, but observational productivity is dependent on environmental conditions. Productivity of the study can be negatively impacted by heavy rain or snow, as it can degrade the quality and genetic material of the spraint.
According to our decided criteria, previously stated as being animal safety, data integrity, and application ease, we conclude spraint to be the best method of marking. Although radiotelemetry provides valuable data, spraint is the better method because it doesn't cause discomfort or endanger the sea otters. Radiotelemetry tends to stress out the otters at an unhealthy rate and has a more strenuous application process. The use of natural markings, while a good method from the otter's perspective, has too many gaps in research and also has a time-consuming process. Therefore, when animal welfare, data accuracy, and ease of application are the important considerations, spraint is the best method to use.